So here you see some molecules over in this board, and I would like you to take some time to recall and recognize this functional group. And the second activity for this is to look at each molecule and try to get out what is the molecular formula. How many carbon atoms are there? How many hydrogen atoms, oxygen, nitrogen, or other elements if there's any. So let's start by this molecule here. Right at the corner, I see that there's a hexagon with alternating double bond. This is a benzene ring. Okay, so let's count the number of carbon atoms. 1, 2, 3, 4, 5, 6. And don't forget there's one more here. So in total, there are 7 carbon atoms. And as we know, each carbon must have 4 lines emerging out, and since nothing's being shown except for this line, so automatically there are 3 hydrogens from this carbon, 1 from that carbon, 1 from the one below, 1 here, right? Do you see? 1, 1, and 1, right? So 1, 2, 3, 4, 5, 6, 7, 8. So C7H8. This is called methylbenzene because this part here is a methyl group that came from a methane and is joined to a benzene ring. So methylbenzene for you. Next molecule, remember this functional group? COC single bonds. So that is a ether. Ethers are quite unreactive. They are used as industrial solvents. Very flammable. So let's count. 1, 2, 3, 4. So in total there are 4 carbon. So C4, right? How many hydrogens? This connects to 3 hydrogens, 2, 2, and 3. So in all, H10. Don't forget the oxygen in the middle. That's the O. For this case, it is an alcohol. That's right, alcohol, because I see a OH, carbon OH. Now some of you may wonder, why do we have to put the H here? Why can't we just do this? Because you may have thought that, oh, like carbon, if I do not show anything, it means automatically you have hydrogen coming out. But that's only true for carbon atom. It's only a prerogative for carbon, not for any other elements. So if you know that there is a hydrogen or there are hydrogens surrounding, let's say nitrogen, oxygen, right, you have to show it to us by sketching the H. So alcohol, true carbon alcohol, that's an ethanol. Again, let's count. 1 and 2 carbon. Here, this carbon joined to oxygen. That's the end. 1 and 2 carbon. So ethanol, right? 3 hydrogens, 2 in the middle, and don't forget 1 at the end. So we can translate this to a CH3, CH2OH. You see, you read CH3, CH2OH. Next up, I see a alkyl chain that is connected to a chlorine, a halogen. So this is called a alkyl halide or halogenal alkanes. So in total, 1, 2, 3. C, 3, H. How many? 1, 2, 3, 4, 5, 6, 7, right? Cl. So that's the formula. Next up, this is a double bond, a carbon-carbon double bond, and next to it we have a nitrogen with some groups. So that is a enamine, alright? Alkene joined directly to a amine. This carbon right at the terminal end, showing you 2 bonds, that means there are 2 not shown and they must be hydrogen. This carbon I'm pointing to now, you see 3 lines emerging out. That means the last bond, again automatically, means hydrogen. This is being shown because this is not carbon, you have to draw out the H. And it ends off with another carbon. Don't forget here, so it's CH3. So you total them up, 1, 2, 3 carbons, so C, 3, H, how many? 3, 4, 5, 6, 7. 7, N. Right. For this molecule here, right, I will box it up. So 1, 2, 3, 4. 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hope you're following. If not, I'll just do it quickly for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, next up, I see a double bond connected to a nitrogen. And take note here, there's a little break. This is actually a carbon. So CN triple bond means it's a nitrile group. It's a nitrile. And again, 1, 2, 3 carbons. So C3, H. 1, 2, 3, 4, 5. Right? H5, N. Now take note, this carbon here, there are no more hydrogen because I have already shown you 1, 2, 3, 4, 4 bonds. You have maxed it out. You can't fit in any more atoms around it. So no hydrogen for this carbon, and that's all. For the next molecule, I see CC double bond. That is an alkene functional group. An alkene. So let's do it fast. 1, 2, 3, 4, 5, 6. C6. If you remember the formula for alkene, CnH2n, we know that n right now is 6, so 2n would mean 12. Ta-da! Right. And don't forget this one over here, 3 lines of equal length. This to us means it's a carbon-carbon triple bond, an alkyne. Alright, so what is this formula? Carbon with 3 lines, so 1 bond not shown must be, yes, you got it, hydrogen. So this molecule is called ethyne. Right, that's right, I'll give you a tick. In exam, this is actually a propane. So, let's do some math. An equal sign to us, or at least to me, this is a 2-carbon alkene, so ethene. And suppose you see this somewhere. Some people might think X is equals to Y, but to me, this is an alkane that's branched. 1, 2, 3, 4, 5. 5 carbons, C5H12. And this is a C2H4 alkene, and that is a 1, 2, 3, 4 C4H10 branched alkane. To me, this is what it represents. So do not be disheartened if you see a lot of C5H12 in your question paper when you do your assessment. These are just alkane.